October 9th, 2022 began like any other day on Earth until observatories across the planet suddenly detected a blast of energy unlike anything scientists had ever recorded. Within seconds, satellites designed to study the violent universe were overwhelmed by an immense surge of gamma radiation arriving from deep space. The explosion was so powerful that detectors had to struggle to measure it correctly because the signal exceeded normal limits. Astronomers quickly realized they were witnessing something extraordinary. The event was later nicknamed BOAT, the brightest of all time, and it instantly became one of the most important cosmic discoveries in modern astronomy. What made the event even more astonishing was its unimaginable distance. The source of the blast was located nearly 2.5 billion light-years away from Earth. That means the radiation reaching our atmosphere had begun its journey long before complex life ever appeared on this planet. For more than 2 billion years, the light raced across the universe until it finally slammed into Earth's upper atmosphere in just a few seconds. Even from that impossible distance, the energy was so intense that it disturbed the ionosphere, the electrically charged layer of the atmosphere located high above the surface. Scientific instruments around the world detected unusual atmospheric changes immediately. Humanity was never in direct danger, but researchers understood something terrifying in that moment. If an explosion like this happened much closer to Earth, the consequences could be catastrophic. Gamma-ray bursts are considered the most energetic explosions known in the universe. In only a few seconds, they can release more energy than our sun will produce during its entire 10 billion-year lifetime. These events are so violent that they briefly outshine entire galaxies containing hundreds of billions of stars. Scientists divide gamma-ray bursts into two major categories because they originate from very different cosmic disasters. The first type is known as a long gamma-ray burst. These bursts usually last longer than 2 seconds and are linked to the deaths of extremely massive stars. When a giant star 20 or 30 times heavier than the Sun finally exhausts its nuclear fuel, its core collapses inward with unimaginable force. Gravity crushes the center of the star in less than a second, forming either a neutron star or a black hole. At the same time, enormous jets of matter erupt outward from the collapsing core at speeds approaching the speed of light. These jets punch through the dying star and explode into surrounding space. Inside those jets, particles collide violently and produce massive amounts of gamma radiation. Astronomers believe the BOAT event belonged to this category because of its enormous power and duration. The second type is called a short gamma-ray burst. These events last less than 2 seconds and are created by collisions between incredibly dense objects such as neutron stars or black holes. A neutron star may contain more mass than the Sun packed into a sphere only a few miles wide. When two of these extreme objects spiral toward each other and finally merge, the collision releases a colossal burst of energy along with gravitational waves that ripple through space and time itself. Scientists have only recently developed technology capable of directly detecting those waves, opening an entirely new way to study the universe. Both forms of gamma-ray bursts are capable of threatening life on Earth, but long bursts are generally considered more dangerous. Their energy output is greater, and they remain active for a longer period of time. A direct hit from a nearby long gamma-ray burst could expose Earth to devastating radiation for tens of seconds or even several minutes. In cosmic terms, that is more than enough time to permanently alter a planet's atmosphere. Astronomers have identified several massive stars within our galactic neighborhood that could eventually produce long gamma-ray bursts. One famous example is Eta Carinae, a huge unstable star located roughly 7,500 light-years away. Another candidate is WR104, a star system about 8,000 light-years from Earth. Scientists pay close attention to these objects because the orientation of their rotational axis determines where the deadly jets will travel. If Earth lies directly in the path of one of those jets, the danger becomes far more serious. Fortunately, current observations suggest both systems are probably pointed away from us. Short gamma-ray bursts are still incredibly destructive, yet they are considered less likely to threaten humanity. Their duration is shorter, and neutron star mergers are extremely rare near Earth. Even when such mergers occur, the narrow jets produced by the explosion would still need to align perfectly with our planet. The odds of that happening are extraordinarily small, but not impossible. Imagine standing outside on a normal afternoon while a lethal cosmic beam invisible to human eyes suddenly tears across the atmosphere above you. There would be no warning sirens, no earthquake, no explosion in the sky. Gamma radiation carries no sound, smell, or visible color. Most people would continue their daily routines completely unaware that the planet's protective shield was already beginning to fail. Within moments, the upper atmosphere would absorb an immense amount of energy, triggering chemical reactions capable of destroying much of the ozone layer that protects life from the sun's ultraviolet radiation. Scientists estimate that a nearby burst aimed directly at Earth could remove half of the ozone layer in a very short time. Without that shield, dangerous ultraviolet light would flood the surface during every daylight hour. People outdoors could suffer severe burns rapidly, and eye damage would become common even after brief exposure. Crops would wither under the intensified radiation, and ecosystems would begin collapsing from the bottom upward. The first victims would likely be microscopic organisms floating near the ocean surface because they are extremely sensitive to ultraviolet exposure. Those tiny organisms produce much of Earth's oxygen supply, meaning the destruction of marine plankton could eventually threaten nearly every complex species alive worldwide. As the oceans began losing microscopic plankton, the entire food chain would start collapsing with terrifying speed. Small marine organisms that depend on plankton for survival would disappear first, followed by fish populations, larger predators, seabirds, and marine mammals. Entire ecosystems that took millions of years to evolve could unravel within a relatively short period of time. On land, forests and crops would also suffer from relentless ultraviolet exposure. Agriculture would fail across huge regions, creating worldwide famine and social collapse. Even if some people survived underground or inside protected shelters, civilization itself could be pushed to the edge of extinction. Scientists believe an event similar to this may already have happened in Earth's distant past. Around 450 million years ago, during the late Ordovician extinction, nearly 85% of marine species vanished. One theory suggests that a nearby gamma-ray burst may have stripped away much of the ozone layer and triggered catastrophic environmental changes across the planet. There is no absolute proof, but the possibility demonstrates how vulnerable life can be to violent events occurring far beyond our solar system. Fortunately, the probability of a civilization ending gamma-ray bursts striking Earth is extremely low. For such a disaster to occur, several unlikely conditions would need to happen simultaneously. First, a massive star would need to collapse, or two neutron stars would need to merge within roughly 6 to 8,000 light-years of Earth. Although that sounds distant, it is considered relatively close on the scale of the Milky Way, which stretches across about 100,000 light years. Second, one of the narrow radiation jets produced by the explosion would need to point directly toward Earth. Gamma-ray burst jets cover only a tiny fraction of the sky. Most explosions fire harmlessly into empty space where no planets are affected at all. Astronomers estimate the chance of Earth sitting precisely inside one of these beams is extremely small. Third, the explosion would need to occur during humanity's existence. Dangerous gamma-ray bursts may happen only once every few hundred million years in our region of the galaxy. Human civilization has existed for only a